this video lecture, we'll be solving this problem, design hit counter. This is a LeetCode medium problem and a very popular interview task. So in this problem, we have to design a hit counter. A hit counter is basically a program which supports the functionality of accepting a hit and returning the number of hits done in the last 5 minutes or 300 seconds, and each call is made with a time stamp which is given in seconds, and it is possible to receive several hits arriving at the same time. All the calls are done in chronological order, and the timestamp for a call is equal to or greater than the timestamp for the call just before it. So the timestamps for each call are consecutive and the initial timestamp is 0. So let's better understand the problem statement using an example. So first of all, let's understand what is a hit counter. Basically, hit counter is a piece of code which is embedded in a web page that track visitors on that web page. And using the hit counter, we can extract the data like how many visitors visited my website in the last month or 5 days or for a certain interval of time, and I can also keep track of the number of newly visiting visitors on my web page. These are some famous examples of hit counters. Basically, you can observe the hit counter gives me two functionalities. One functionality is to simply record the hits, and the hit in the case of a web page is basically a visitor which visits that web page at a particular timestamp or an instance of time. So a timestamp represents an instance of time, while a hit can be some certain visitor, a time clock in a stopwatch. The another functionality, generic functionality that I require is to count a certain data or find a certain data, the number of visitors or the number of hits in a more general sense in a particular interval of time. So this is the kind of program that we want to develop. Let's see how the input for that problem will be given to us. So in the input we will be given two types of integers, where type 1 is represented by 1 and type 2 is represented by 2. So, and in each line, so we get an array of size n, where each element is a pair of integers, where the first integer represents the type of the functionality that we want to perform and the second one represents the timestamp. Fine. So if we have a type 1 functionality where the first integer is 1, we have to record a hit at that particular instance of time or timestamp. Otherwise, if we have type 2 functionality, then we want to return number of hits in the 5 till the given timestamp, and in the output we have to return the answer to the type 2 queries, that is the number of hits which are encountered in last 5 minutes. So let's better understand the exemplar input test data. So here we have our input set. So this is the input array, and the input array contains these 7 pairs, where each pair has 2 integers. First integer represents the type and the second integer represents the, so first we encounter a type 1 query where we want to record a hit at time 1. So this second integer represents the timestamp. So this second integer represents the timestamp, and this is the function call that we want to do for that particular timestamp. So we call our hit function at timestamp 1. Then in the next query we again have type 1 query where we call the hit function at timestamp 2, and so on. Then in the fourth query we can see we have a type 2 query and the timestamp is 3. It is saying give me the number of hits that I have performed in the last 5 minutes till timestamp 3. Then we encounter our second type of query where the second integer is 4, and here what we are saying that give me the number of hits in the last 5 minutes till timestamp 4. So that's why I'm calling this function getHits, which simply gives me the number of hits in the last 5 minutes till timestamp 4. So here I'm passing timestamp in the argument, and so on. So these are the two type of queries that we want to answer, while in the output all we have to return is the answer to these type of queries, because the hit function is simply marking the timestamp, while the get hits returns me an integer representing the number of hits that are performed till that timestamp in the last 5 minutes. So this same timeline can be represented in this number line, where we are performing the hits at timestamp 1, 2 and then 3, and then we are getting the hits at time 3, and then we are performing the hit again at timestamp 300, and then we are calling our get hits function again at 300 and 301. So what will be the answer to this first get hits function call? We can see that the number of hits that I have encountered in 5 minutes, in the last 5 minutes, or so in the last 300 seconds is 3. So you can count 1, 2, 3. We have encountered 3 hits in the last 300 seconds. Then what will be the answer to this function call? That is the number of hits in the last 5 minutes till timestamp 300. Here, till this point, we can see that the number of hits are 4, because till this time, starting from the timestamp 1 up until 300, we have encountered 300 timestamps, and in 300 timestamps or seconds. So each timestamp basically represents a second, an instance at which the hit is made. So we have 3 seconds till this get hits function is called, and in this, so we have 300 seconds until this get hits function is called, and in these 300 seconds we can see that we have made 4 hits, and hence the answer for this get hits function would be 4. Then for this 301, we are calling this function get hits and passing the argument 301. That is, we are saying what are the number of hits that I have performed till 301. So we have 301 seconds till this point, and we want to record the hits in the last 300 seconds, that is in this portion only, starting from 2 till 301, and the number of hits in this portion are 3, 1, 2 and then 3 here. Hence the answer for this function is 3. This is how the code must work, and this is a typical hit counter that we require. Let's see how we can implement a typical program for implementing this kind of functionality. So the intuition is simple. At any instance, we need two type of functions. The first function is hit function, which takes in our timestamp and simply records this timestamp in some data structure. Then the second function is get hits function, which again takes in the timestamp and it simply counts the number of hits in the last 300 seconds. So which type of data structure can be used to solve this problem? So we can simply use a doubly ended queue where we can record these hits, and then whenever the number of hits are required, we simply resize our queue so as to get the number of hits in 300 seconds. So what do we need? Why do we need a queue here? It's because we require two functionalities. We simply want to record the timestamps, and whenever the get hits function is called, we want to extract the last 300 seconds or the timestamps in the last 300 seconds. So if we have 300 seconds in this particular range, then we want to remove any excessive timestamp if we have before these 300 seconds, because they are unnecessary for any get hits function which are called after this point, including this point itself, because all we require are the timestamps in the last 300 seconds. So let's say the get hits function is first called at this position, then obviously it will be called after this timestamp, somewhere here. Then we require the last 300 seconds again, and we do not require this part here, and we just delete this. So this is the logic. We simply remove the excessive portion. We want to remove the excessive portion which is beyond 300 seconds. So that's why we are using queue here. Fine. So let's run this algorithm on the given test data. This is our queue. This is the back of the queue. This is the front of the queue. Initially, we call hit function at the first timestamp. So we record our first timestamp in the queue. Then we record our second timestamp in the queue. Then we record the third timestamp in the queue for the corresponding hit function calls. Then we come across the get hits function, which has the argument as 4, and it says till the timestamp 4. It simply states till the timestamp 4 extract the number of number of hits in the previous 300 seconds. That's what we require here. So how do we do that? So let's call this current timestamp as timestamp. Then we have to subtract that extra portion which is beyond this 300. So we start from the back of this queue and we extract the very first element, that is queue dot front, and this portion must be equal to 300 because that's what we want to keep in our queue. We just want to keep the hits in our queue which lies within the range of these recent 300 seconds. So that's all we require. And if there are excessive seconds, then we simply remove them. But here you can see that the current timestamp is 4 and the front element is 1. This is very small than the 300 seconds. That means we do not have to remove any element from the queue so as to count the number of hits, because in this case the size of the queue, namely all the hits that I have performed, will be the answer, because we haven't elapsed the enough time. We have just elapsed 4 seconds, while to remove the elements from the queue we at least require 301 seconds, so that we decrease the range of the timestamps to 300. But here the range is already 3, hence we do not have to remove any element. So the answer is 3, which is the size of this queue. Then we push 300 in the queue, which is the next timestamp, and then we again call the get hits function at 300. So we can see that the range that we have is from 1 to 300, and the size of this range is 300. So the current timestamp is 300, while the first element that we have in the back of the queue is 1, and this again goes lesser than 300. That means we can record all the hits that are present in the queue, and there are 4 hits in the queue. Then we go to the next get hits function call, which is 301. Now the timestamp has gone 301. We have elapsed 301 seconds till now. Fine. And 301 minus the front element of the queue, which is 1, it is indeed equal to 300. That means we need to remove the first element to get our range of 300 timestamps, and hence we remove this 1 from the queue and we get 3 element, and hence the answer for this function is 3. So let's see the implementation for this solution. So in the implementation we simply take a queue. So in the implementation we simply take an empty queue. We design this hit function. It's a very simple function. All it does, it takes the timestamp and it pushes into the queue. Then in this get hits function we run a while loop which simply runs till the queue is not empty, and the range that we have from the current timestamp till the first element of the queue or the front element of the queue must be greater than or equal to 300. That we are counting the number of hits in the last 300 seconds or timestamps, and we are popping the extra elements from the queue. Finally, we return the size of the queue right from here, which represents the number of hits which are performed in the last 300 seconds or 5 minutes. Pretty easy implementation. We can discuss the time and space complexity right here. We can see that the time complexity is constant because all it is doing is just performing a push operation, while the time complexity for this get hits function may go up to big of n if n are the number of ranges in the queue in the given input. Fine. And That's all. And the space complexity is linear because I'm using this queue here. So this is a very naive implementation of a typical hit counter. So this is the time and space complexity, and it is a very naive implementation of a typical hit counter. So this is a very naive implementation of a hit counter. We have to handle certain cases like when there is a concurrent access or concurrent hits and the data comes in unordered format. We'll learn to handle those cases in subsequent videos, but for this video, all I have got is this naive implementation for the hit counter. Let's move on to the code implementation for this solution. So this is our hit counter class. It simply initializes a queue here called hits. Then we have a constructor called hit counter, which is used to initialize the data structure here. Here we have our hit function call, which simply takes in the timestamp and push it into the queue. Then we have our get hits function, which takes in the timestamp, and we run this while loop till we get the range of 300 seconds, and we keep popping the excessive timestamps, and finally we return the number of hits which are remaining in the queue. So this is the implementation in C++. Let's see the implementation in other language. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then do like it and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.